Hello and welcome to Amar Astrobytes, where we bring you stories about astronomy in bite-sized chunks. My name is Michael Burton and I am the director of the Observatory and Planetarium here in Amar. Today's Astrobytes will take us on a tour of our solar system. In part 1, we begin with the inner planets. Since the first spacecraft was sent to Mars and Venus in the early 1960s, humanity has been the spectator for 60 years of the great voyages of discovery around our solar system made by these robotic probes. They have revealed a bewildering variety of new worlds. Here we see the Sun and the major bodies of the solar system, which we call planets, all shown to scale. 4 inner rocky planets, Mercury, Venus, Earth and Mars, 2 gas giants, Jupiter and Saturn, and 2 ice giants, Neptune and Uranus. This slide shows the planets at their relative locations from the Sun. The Earth is 150 million kilometers from the Sun, 1 astronomical unit, as we say. Light takes just 8 minutes to travel this great distance. But on this scale, the planets themselves are far too small to be seen. The planets all lie in a disk, a fossil record from the formation of our solar system 4.6 billion years ago that helps us understand how the Sun and the planets were formed. Except for Pluto, 40 times further away than the Earth, which gives us a clue for why it is no longer regarded as a planet. We'll come back to this matter in another Astrobyte. For now, notice how the inner planets tightly clustered and relatively close to the Sun. We begin our journey with our home planet, Earth. Here we see continents, tectonic plates floating on lava beneath, with vegetation and deserts apparent on their surfaces. Surrounded by oceans, the only place in the cosmos where we have so far seen liquid water on the surface. Ice caps at the poles and clouds of water vapor across the globe, constantly changing, a dynamic, living planet. The Earth is also remarkable in having a moon a substantial fraction of its own size. Here we see the Earth and Moon can be considered as a double planet system, from an image taken by the Galileo satellite en route to Jupiter. The Moon's large size results in substantial tides on Earth, as well as stabilizing its axis of rotation, vital for maintaining relative climatic stability over the eons. The Moon is about 400,000 kilometers from us, much closer than any of the planets. Close enough that humans have ventured there in the Apollo program of 50 years ago that successfully landed 12 men on the Moon and brought them home again. The Moon is 1/4 the size of the Earth, but a dead world without an atmosphere. The surface is covered in a fine dust or regolith, the results of eons of bombardment by micrometeorites pulverizing the rock, a process that astronomers call gardening. The closest planet to the Sun is Mercury. It is on the left in this picture, but looks rather like the Moon, its surface covered in craters. Less than half the Earth's distance from the Sun, the year is just 88 days long. With the thinnest of atmospheres, the daily temperature range is extreme, from 350 degrees centigrade in daytime to minus 170 degrees centigrade at night. However, the day lasts for 2 Mercury years. Now we turn to Venus, Earth's big sister, and very similar in size, but a very different and hostile world. A toxic atmosphere with droplets of sulfuric acid 90 times the pressure of Earth, so hot on the surface that lead could melt, the result of a runaway greenhouse effect. Radar lets us peer through the thick clouds to reveal great continents, highlands, faults, and fractures. Aphrodite Terra, a continent 16,000 kilometers across, runs across the center of this view. Venus is a volcanic world, scarred by impacts. This 3D view, recreated from Magellan satellite's radar, is of a highland region called Estella Regio. It shows a volcano called Gula Mons, 3,000 meters high, to rear. In the foreground is an impact crater 50 kilometers across, the result of an asteroid smashing into Venus in the distant past. Next we head to Mars, Earth's little brother, a world half the size of the Earth but with many characteristics that appear similar. Polar caps, but dominated by carbon dioxide ice, not water ice. Clouds of water ice, but with atmospheric pressure just 1% of the Earth's. Seasonal variations are apparent during Mars's 2 Earth-year long year, as the tilt of the planet's axis to the orbit about the Sun is similar. Mars has geological features that are seen on Earth, such as volcanoes and canyon systems. However, their scale is immense. Here we see the volcano Olympus Mons, 24 kilometers high, it is 3 times the height of Everest. It is also 600 kilometers across, the size of France. A shield volcano, it formed in a similar way as the Hawaiian Islands on Earth, through a hot spot in the Martian crust. But Mars is now geologically virtually dead. Its internal heat engine has shut down. Olympus Mons is extinct. This is a canyon system on Mars with the entrancing name of the Gorgonum Chaos. If it wasn't for the lack of water and vegetation, it might be the Grand Canyon here on Earth. Gully systems are clearly seen. It is speculated that these were caused by flowing water long, long ago, perhaps from an underground aquifer or from glaciers which once existed on the surface. The fact that liquid water once flowed on Mars is intriguing. Early in the 4.6 billion year history of the solar system, Mars would have had a thick atmosphere. Its molten surface would have cooled more rapidly than the Earth's. Could life have formed on Mars before on the Earth, but then gone extinct as the atmosphere was lost in the weaker Martian gravity? We do not yet know. We end today's Astrobytes with an image of Curiosity rover exploring the surface of the Mars. A selfie taken by the robot on May the 29th, 2019. Among its mission goals is searching for clues to this great question. Thank you.